any given rational function can be expressed in terms of different simple fraction. That is called as partial fraction. For any polynomial of degree n, their numerical coefficient is not equal to 0. So improper function or improper rational fraction as a sum of polynomial and proper rational function. So how we will divide it? We will see so that the first terms are same. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysore. So in today's session, I'll be taking of partial fractions. So in today's session, let us start with the new chapter called partial fractions. So what do you mean by partial fractions? So before that, let me start introducing to the chapter of partial fraction. Then we will be knowing about polynomial function. So you're already familiar with this polynomial function. And next we go for the rational function and the types of rational function. And finally, how an improper rational functions or fractions can be written as a sum of polynomial and proper fraction. So these are all the contents we are going to discuss it on today. So let's start. Now, what do you mean by partial fraction? So writing any rational function or any rational fraction in simple fraction is nothing but partial fractions. Okay, so any given rational function can be expressed in terms of different simple fraction. That is called as partial fraction. For example, here I have taken two fractions. Okay, so that is 3 by x plus 1 plus 2 by x minus 2. When you resolve it or when you simplify it, that is 3 by x plus 1 plus 2 divided by x minus 2. When you simplify it, the answer is this, 5x minus 4 divided by x plus 1, x minus 2. So what is this? This is now an example for a rational function or rational fraction. So when you split these rational function into simple different fractions, these are called as partial fraction. So you are going to write this fraction into two different or the sum of two different simple fraction, that is called as partial fraction, and the process of writing the rational function or rational fraction into two simple fraction is called as resolving into partial fraction. So resolving into partial fraction is nothing but, so writing any rational function or any rational fraction into two simple partial fraction is called as resolving into partial fractions. So before going to partial fraction, so let me have some important terms. That is, the first one is polynomial function. So what do you mean by polynomial function? You have learnt in your secondary classes about polynomial. So that polynomial is also a function. So this polynomial can be expressed in the general form, that is a naught x power n plus a1 x power n minus 1 plus a2 x to the power n minus 2 plus an, where an is the last term of the polynomial. Whenever we write any polynomial in its standard form, the last term will be the constant. And the first term a naught is always not equal to 0. So where a naught, a1, a2, an are constant, that is they are all numerical coefficient. They will have some numerical value, and the power of x is written in the decreasing order. That is, this is the standard general formula for any polynomial function. So this is, here I have chosen a variable x we can choose any variable other than x also, and here we have a polynomial of degree n. So degree is nothing but the highest power of the variable in a polynomial. So here x is the variable and its highest power is n. So therefore it is a polynomial of degree n. I'll take one more example. So you can look here, 3x to the power 7 minus 7x power 5 plus 13x cube plus 8. So here this is in the standard form. So standard form is nothing but writing a polynomial in the decreasing order of its powers of a variable. So it is a polynomial of x degree 7 because the highest power of x is 7. So whatever the highest power of x may be, the constant must not equal to 0. So that is why here the first term a0 is not equal to 0. For any polynomial of degree n, their numerical coefficient is not equal to 0. Second example, x square plus 5x plus 6 is a polynomial in x of degree 2 because the highest power of the variable here is 2, therefore its degree is 2. And all non-zero constant. Why they are called as non-zero constant? Here this is an example for non-zero constant. So they have a polynomial of degree 0 because when you write a polynomial as 9 is also polynomial. Suppose if its variable is x, then the power of variable is 0 there. Since anything to the power 0 is always equal to 1, so 9 is called a constant polynomial with degree 0. Any constant polynomial have the degree 0. Next, we come across one more function, that is rational function. So what do you mean by rational function? So rational function is of the form f of x by g of x, where both f of x and g of x are polynomial and g of x cannot be equal to 0. It is not equal to 0 because in the denominator. So therefore, any function of the form f of x by g of x, where f of x and g of x are polynomials and g of x not equal to 0, is called rational function or rational fraction. So here is few examples for rational functions I have given. So 8x square minus 5x plus 2 is a polynomial, 3x cube plus 4x minus 9 is a polynomial, and this is not equal to 0. So this is in the form of f of x by g of x, and here is also one more example where f of x and g of x are both polynomials and g of x is not equal to 0. So these are the examples for rational function. So rational function means the function which is in the form of f of x by g of x, where both f of x and g of x are polynomial and g of x is not equal to 0, is called rational function or rational fraction. Next, in rational function, we have two types. How you have a different types in fraction, that is proper fraction and improper fraction. In the same way, here we have for a rational fraction also. So we have proper and improper rational fractions. So what do you mean by proper and improper fraction? In proper fraction, so the degree of the numerator polynomial is less than the degree of the denominator polynomial. Example, here you can observe example 1. 8x square minus 5x plus 2. So what is the degree of the polynomial here? Here it is 2. What is the degree of the polynomial here? Here it is 3. So whenever the degree of the numerator polynomial is less than the degree of the denominator polynomial, then it is called as proper fraction or proper rational fraction. Then what do you mean by improper rational fraction? Vice versa. If the degree of the numerator polynomial is greater than or equal to the denominator polynomial, then we say that it is an example for improper fraction. For example, I can write x plus 1 divided by x plus 3. So here both f of x and g of x have the same degree, that is 1. So therefore, this is an example for improper fraction. One more I can take, x cube plus 3 divided by x plus 3. So here the degree is 1, here the degree is 3. So the degree of the numerator is greater than the degree of the denominator. So this is also an example for improper rational fraction. Next, now if we have a rational fraction which is improper, we can write it as a sum of polynomial and proper fraction. We can convert them into as a sum of a polynomial and a proper rational function. So how to do it? We'll see it now. So improper function or improper rational fraction as a sum of polynomial and proper rational function. So how to do that? So we have learned in our high school how to divide the polynomials. So the same concept is used here. So look here, I have x square plus 1 divided by x square minus 5x plus 1. What is the degree of the polynomial here? So here it is 2. What is the degree of the polynomial here? It is 2. So whenever the degree of both numerator and denominator polynomial is same, this is an example for improper fraction or improper rational fraction. So how to convert this into a sum of polynomial and proper fraction? By the method of division of polynomials. We'll divide now. X square minus 5x plus 6, x square plus 1. So we have x square on both sides. So I'll just multiply with 1. X square into 1, x square. We have minus 5x. Minus 5x into 1 is again minus 5x. Plus 6 into 1, we have plus 6. So we have to subtract it so that we'll change the sign. So this is minus, plus, minus. Now, minus x square plus x square get cancelled. We don't have any x term here. So here we have a x term. That sign is changed. So minus 5x has become now 5x. Here we have a constant 1. Here we have a constant 6. But now it is minus 6. So 1 minus 6 is minus 5. We cannot divide it further. Why? Because the degree of this polynomial is less than this. So here its degree is 1 and here the degree is 2. Okay, so now we can't divide it. But how we can express this as a sum? So now this is the remainder. Okay, so now how we will express this? So this and this is the quotient. So therefore this can be written as 1 plus. So this is 5x minus 5 divided by the divisor. So that is x square minus 5x plus 6. So that is if you have two numbers a and b. Okay. If its quotient and remainder are given by q and r. Okay. So how you are going to write a as b into q plus r as a sum of remainder and its product along with its quotient. So in the same way, we have to express it as a polynomial and proper fraction. So here 1 is a constant polynomial and this is a proper rational function. Why? Because the degree of the numerator is less than the degree of the denominator. So this is how we will express any improper fraction as a sum of polynomial and proper rational fraction. We'll take one more example. 3x square minus 4x plus 7 divided by x plus 7. Clearly we can say it is an example for improper rational function. Why? The degree of the numerator is greater than the degree of the denominator. Here the degree is 2, here the degree is 1. So therefore this is an example for improper rational fraction. So how to express it now? divide it using division of polynomials. So x plus 7 divide 3x square minus 4x plus 7. How to divide it now? By multiplying so that the first term will become same. Here you have 3x square, here you have x. To make this as 3x square, I need 3x. So 3x into x becomes 3x square. Next, 3x into plus 7 becomes plus 7 3s are 21x. Now we have to subtract. So change the sign to minus minus. Plus 3x square minus 3x square get cancels. Both have minus sign. So we have to add it. So this becomes minus 25x plus 7. So the only numerical constant term here is 7. So write it in as a polynomial function. Now again we can divide it because we have the same degree. So when you have same degree, you can divide it. So what is required here? Here we have x. I need minus 25. So minus 25 here. Now minus 25 into x minus 25x. Minus into plus minus 25 sevens are 175. Again subtract. To subtract, you have to change the sign. Plus minus 25x plus 25x get cancels. 7 plus 175 is 182. So you have a remainder 182. So now how to express this? Write 3x minus 25 here plus what is the remainder? 182. So 182 divided by x plus 7. Now we will learn how to write an improper fraction as a sum of polynomial and proper fraction. How we will do it? By using the concept of division of polynomials. So here is an example, x square plus 1 divided by x square minus 5x plus 6. This is clearly an example for improper fraction. How? Because the degree of x 2, here the degree of x is again 2. So you have same degree in both numerator and denominator. Therefore, this is an example for improper rational fraction. Now, we will write it as a sum of polynomial and proper fraction. So, we'll divide it now. X square minus 5x plus 6 whole divided x square plus 1. So, how we will divide it? We'll see so that the first terms are same. So, here x square and x square is same. So, we will multiply with 1. So, 1 into x square is x square. 1 into 5x minus 5x. 1 into 6 plus 6. What you will do? You will subtract. So, you should change the sign. Minus, plus, minus. Now, plus x square minus x square get cancelled. Here you don't have any x term. Here you have, but it is now 5x. So, 5x plus 1 minus 6 is minus 5. So, this can be written now. This is equal to, so 1 is the 1 plus, so 5x minus 5 whole divided by x square minus 5x plus 6. So, we can't divide it further because the degree of the numerator is less than the degree of the denominator. You can see here you have x square, here you have 5x. So, you can't divide it further. So, therefore, we'll write it in terms of proper rational fraction. So, therefore, here 1 is a constant polynomial and this is a proper fraction. So, therefore, improper is now converted as the sum of polynomial plus proper fraction. Next, we'll take one more example. 3x square minus 4x plus 7 divided by x plus 7. What we are supposed to do? We will divide it. So, x plus 7, 3x square minus 4x plus 7. Now what happens here? You have term x here, here 3x square. So x should be 3x square now. So for that I should multiply 3x to this term. So therefore multiply 3x. 3x into x is 3x square. 3x into 7 is 21x. Plus you have, so therefore it is plus. Again you have to subtract, so change the sign. Minus, minus. Plus 3x square minus 3x square cancels. Both you have minus. Minus 25x plus 7. You can divide it because they have same degree, 1 and 1. Now here it is x, here it is 25x, minus 25x. So we have to multiply with minus 25. Minus 25 into x is minus 25x. Minus 25 into plus 7 is minus 175. Again subtract, change the sign. Plus, plus. So minus 25 plus 25x cancel. 7 plus 175 is 182. So how we will express this? As a polynomial here, that is 3x minus 25 plus. So we can't divide again. So that is 182 divided by x plus 7. So now this is a polynomial and this is a proper fraction because degree of x is here 0 and degree of x is here 1. Numerator degree is less than the degree of the denominator. Next we'll take one more example, 5x square divided by x square plus 4x plus 3. So here the degree is 2, here also the degree is 2, clearly improper fraction. Now we will express it as a sum of polynomial and proper fraction. So how to do it? Again divide it. So divide from x square plus 4x plus 3. 5x square. Now you have x square here but 5. So multiply 5. So what happens? 5 into x square, 5x square plus 5 4s are 20x. Again plus 5 3s are 15. Change the sign. Minus, minus, minus. Plus 5x square minus 5x square cancel. You don't have any x term here. So only write 20x, but now sign is changed to minus. So therefore minus 20x. No constant term here. Here you have minus 15. So now you can observe, you can stop here because the degree of this is less than x square. So you should write it in terms of proper fraction and this as a polynomial. So therefore this is equal to 5 plus minus 20x minus 15 divided by x square plus 4x plus 3. So this is how we will write any improper rational function as a sum of polynomial and proper rational fraction or function. So this is a very important concept in resolving partial fractions. That is, whenever a rational function is written in different simple fraction, so writing improper fraction as a sum of polynomial and proper fraction is very important. So whenever you come across a improper rational fraction, so before resolving it, you should know the concept how to split improper fraction as a sum of polynomial and proper rational fraction. So in the next class, we will study how to resolve any rational fraction into simple partial fraction. So in today's class, we have learned in detail about how a rational function looks like and what are its types. So we will learn how to resolve a rational fraction in the next session. So I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.